Welcome back for your second day of arithmetic series. So once again, we're going to be talking about series where we're adding between every term. Today we're going to throw in a new curveball though and introduce something called summation notation. This becomes important in a lot of summation things. So summation notation looks like this. All right, so what it's doing is it's giving you the explicit formula right here. Okay, so it gives you the explicit formula and it's telling you to evaluate it from when n is 1 all the way up to when n is 5. So basically it's a shorthand way of generating a series because when n is 1, what is that? Well, 3 times 1 plus 1 is 4. When n is 2, what is it giving you? Well, 3 times 2 is 6 plus 1 is 7. When n is 3, it's 10. When n is 4, it's 13. When n is 5, it's 16. So basically, it's just a fancy way of writing that series in a shorthand notation, okay? So just picture that, okay? All it's doing is representing a series. So as long as it looks like a linear function. Okay, so notice this, that form looks a lot like y equals mx plus b, right? So if it's a linear function in there, it means it's going to be arithmetic. Okay, so we can still find the sum using the summation formula, but of course now it's going to look a little bit different as we're trying to write out that summation formula. Okay, so let's go through the process of how can we use the summation formula to find the sum of these things. So let's remember first and foremost, your summation formula is this. Okay, so it's asking us to find the sums using that formula. So of course the pieces we're looking for are exactly the same as they were before. I need n, I need a1, and I need an. Okay, three things I need in order to plug into that formula to find the sum. N is going to be really easy. If it's going from 1 up to 70, well, there's going to be 70 terms. Pretty clear cut, right? All right, A1. Well, the first term is just plugging 1 into here. So my first term, when I plug 1 in there, 5 times 1 plus 3 gives me 8. All right, well, AN is just the same, except this time I'm going to plug in 70. So 5 times 70 plus 3 gives me 353. So you can see it's actually really simple to get those pieces of information. And that's all this is. Knowing those are the three pieces you need, so you find them, and now I can use my summation formula. So n over 2, the first term plus my last term. And let's plug that into the calculator. So 70 divided by 2, first term plus last term. 12,635. All right, so let's try it again, shall we? Just to make sure we're feeling confident in this. So I need n, a1, and an in order to perform the summation. N, if I'm going from 1 up to 40, which is going to be 40, I plug 1 into my equation. 3 minus 8 is a negative 5. I plug in 40 to my equation, and I get 112. So now I have the 3 pieces of information that I need. So now let's write it out. Negative 5 plus 112. And that's what I'm going to type in to my calculator. 40 divided by 2, negative 5 plus 112. 2,140. All right. So, again, pretty painless at this point. Let's look at these. So, same story. I'm going to need n, I'm going to need a 1, and I'm going to need a n to plug into my summation formula. 1 up to 30 is going to give me 30. A1, so I plug 1 in here. Negative 2 plus 1 is negative 1. I plug in 30, so negative 60 plus 1 is a negative 59. All right, so number of terms divided by 2. First term plus last term will give me that. So let's type all of this in. 3 divided by 2, negative 1 minus 59. It's going to give me an even negative 900. All right, and let's look at this last one. Still need those same 3 pieces. So n is going to be 1 up to 26. A1, so I plug 1 in. So 1/2 times 1 minus 5, that is going to be negative 4.5. And I plug in 26. So 1/2 times 26 minus 5 is going to give me 8. So 26 over 2, negative 4.5 plus 8. So let's type all that in. 26 divided by 2, negative 4.5 plus 8. And that is going to give me 45.5 for my sum. All right, so now we've practiced finding the sums. Well, you can also go backwards, right? So if I gave you a series, I could ask you to write me the summation. Okay, so it is important to be able to go both ways. So how can I write it in the shorthand? Well, there's a couple things I need. I need the to know where I'm going from. So here I'm going to be bounded between 1 all the way up to n. And then I need the explicit formula. Okay, so to write a summation, those are the things I need. Explicit formula, and I need to know what n is. So here, 1, 2, 3, 4, 5, 6, 7. Well, I already know that n is 7. And in this case, my d is 5. And why am I going to need to know D? Well, if I need the explicit formula, D is very important within that formula, right? Then, of course, my first term is going to be 6. So my first goal, I need that explicit formula. So this is an explicit formula, first term plus n minus 1 times D. D is 5. So notice, because I am actually just trying to get the explicit formula, remember, in the explicit formula, n is meant to be your variable. So I need to leave n alone. Distribute this, 5n minus 5. Oh, so we get 5n plus 1 as our explicit formula. So what does that mean? Well, in my summation, I'm starting at 1, going up to 7, and my explicit formula is that. So that's how I can write it in summation notation, okay? So again, you need to know a lot of pieces because you need to finagle your way to an explicit formula and then n to actually plug in. But in finding those, typically you need every piece. You need D, you need the last term, all those kind of things in order to calculate whatever you need. So let's take a look at this one. So this time n is unknown. I don't know what my n is that I'm going to need. I do know D. Okay, so D is going to be negative 3. And I do know my first term is 5. So I do still have enough to calculate um, my arithmetic or my explicit formula. So let's take a look at that explicit formula. A1 plus n minus 1 times negative 3. So again, in an explicit formula, n is meant to be the variable. So to put this in summation notation, I do need this actually written out. Distribute that, so minus 3n plus 3. So there is my explicit formula, okay? Now, I'm given an endpoint. So now remember, if I need n, I need that endpoint. What that means is now I can go and find that. Using my explicit formula, I can find what n is when my last term is negative 28 or is negative 22. So let's use the explicit formula we found so we can find what this is. Subtract the 8, divide by negative 3. So n is 10 here. So now finally I have everything that I need to write this in summation notation. I'm going to go from 1 up to 10, and my formula, my explicit formula, is that. All right. Now, there is one little hiccup. So we've talked a lot about arithmetic things, okay? But if it's not arithmetic, this summation notation can still be important to you. Just realize that if this is not linear, so this is not linear, this is not linear. So what that means is we can't just use a summation notation, okay? Or we can't just use the summation formula. What it means is I'm actually going to have to just grind out what the terms are and add them together, okay? So let me show you what I mean. I can calculate when n is 1. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. So when you don't have something linear in there, you can actually just write out the terms and add them up. Okay, same thing with this one. So I plug in 1, so 0 squared is 0. I plug in 2, or I plug in 2, so 1 squared is 1. Plug in 3, so 2 squared is 4. Plug in 4, so 3 squared is 9. Plug in 5, so 4 squared is 16. And when I add those all up, I get 30. So when you have to, if you don't, if you're not dealing with something linear, then sometimes you will just have to grind out what are my terms and then add them all up. All right? So we've done a lot of things with arithmetic sequences and series. So I do want to take a moment here to go back and refresh our memories on everything we've done so far. Okay, there's been a lot of good stuff we've worked on, and I want to make sure that we're keeping all of it straight and remembering how to do each of those things. So let's go all the way back and remember explicit and recursive formulas. So if I just give you a sequence, remember recursively, that's where you label out your first term, and then you state in terms of your previous term, what are you doing? In this case, adding 4. All right. So I know it's been a while since we've done anything with recursive formulas, but make sure you're remembering that this is where the chapter began. And obviously, explicit, you've continued to work with quite a bit. First term plus n minus 1, and then your d is 4. So remember, when you're actually writing out the explicit formula, n is your variable. So distribute the 4, so you get 3 plus 4n minus 4. So you get 4n minus 1. And if you're trying to find A14, remember you use the explicit formula, okay? So 4 times 14 minus 1. That's going to give you 55. So that's where all of this arithmetic talk came from, all right? Then don't forget, we also talked about arithmetic means. Remember, arithmetic mean, all you have to do is find the average of those numbers. So in this case, 24 divided by 2 would be 12. And remember, even if you don't have 2 consecutive terms, you can still find the explicit formula and find a future term. Because remember, you have A1, you know n is 5, and you have your future term. The only thing you're missing is d. So remember, if you're missing anything, plug everything you know into the explicit formula, solve for what you don't know, and then go from there. So here, my future term equals A1 plus n minus 1. And right now, I'm using the formula to find d. I'm going to subtract 4. 5 minus 1 is 4. So divide by 4. My d is going to be 9. So now that I know what d is, now I can actually plug it in to write my official explicit formula. A1 plus n minus 1 times d. Remember when you're writing actually the explicit formula? Remember, n is the variable. And now for these linear ones, we're going to clean it up. And of course, if I want A10, Now I just use that formula to do so. 90 minus 5 would give me 85. So as we're progressing through, please make sure that you're going and re-reviewing all those concepts that we've already talked about, okay? All these things are going to be important and all these things are going to be on the test. So we need to make sure we're staying fresh with them. So thank you so much for joining me. So make sure you have all this written out. Write in your summary for me, please, and then come back ready to do your practice work.